In this video, let's find the Fourier series for f as it's defined f of x between negative pi and pi. So f of x is equal to x, and we're going to say that f of x is also equal to 1/2 a naught. This is going to be the Fourier series, 1/2 a naught plus the infinite sum from n equals 1 to infinity of a sub n cosine of nx plus b sub n sine of nx. And now what we need to do is find these coefficients a naught, an, and bn. And to do that, we're going to use some already derived formulas. You can check out another one of the videos on my channel, but they look like this. So a naught equals integral negative pi to pi. A naught equals 1 over pi times the integral negative pi to pi of f of x dx. An equals 1 over pi integral from negative pi to pi of f of x cosine of nx dx. And then finally, b sub n is equal to 1 over pi times the integral negative pi to pi of f of x sine of nx dx. So solving for a naught first, we'll do that. We have 1 over pi times the integral negative pi to pi of x times of x dx. And remember that x looks like this, and we can conclude that it's an odd function. So the area to the right and left of the origin are going to cancel each other out in this integral. And it's a property of odd functions over symmetric intervals that they go to 0. So a sub n equals 0 in this case. And we can move it on to, a sub 0 is equal to 0. And then moving on to an, we have 1 over pi times the integral negative pi to pi of x times cosine of nx dx. Now again, note that this cosine is going to be even, and this x is odd, and properties of odd and even functions, if you multiply those together, will output an odd function. And then again, odd functions over a symmetric interval go to 0, so a sub n equals 0. And now we actually calculate what the Fourier series is going to look like. B sub n is going to be 1 over pi times the integral negative pi to pi of x times sine of nx dx. Sorry, I said sine of x. Sine of nx dx. And with sine of nx dx, we're going to do this with integration by parts, and particularly I like doing it with tabular method. So we do x here, sine of nx here. This column is going to be our integrals. This is going to be our derivatives. And we have sines plus minus plus. Derivative of x is 1. Derivative of 1 is 0. Antiderivative of sine nx is negative 1 over n cosine of nx. And then the integral of that is negative 1 over n squared sine of nx, I believe, right? So if we take a derivative of this, we get cosine, and then an n per term pops out, because of the chain rule. So that works. And following the diagonals, we have negative x over n cosine of nx, then minus, we got two minuses, so that's a plus 1 over n squared sine of nx. And that we're going to evaluate these two from negative pi to pi. And remember, this whole thing's going to be multiplied by 1 over pi. So let's try and tackle this one piece at a time so it's a little bit easier. Let's go with, let's go with this sine term first. So sine of n pi is equal to 0. Same thing with sine of negative n pi. So this term basically fades away, and we're left with 1 over pi times negative x over n cosine of nx evaluated from negative pi to pi. And so what we get with that is 1 over pi multiplied by negative pi over n cosine of n pi, and then subtract negative over n cosine of n times negative pi. And cosine's even, so cosine of n pi equals cosine of negative n pi. So we can simplify this to 1 over pi times negative pi over n cosine of n pi. And then this is 3 minuses, so we get a minus pi over n times cosine of n pi. And so pi's cancel out on every term, and we're left with negative 2 over n cosine of n pi. And that's going to be equal to bn. Let's go ahead and represent this in a better way. So cosine of n pi is going to be equal to negative 1 raised to the n. So if we look at cosine real quick, cosine starts at 1 and does stuff like this, right? So cosine right here so this is 0, this is pi, here's 2 pi, etc. So if we had n is equal to 1, we have cosine of pi, and that's negative 1. So we get negative 1 raised to the 1 equals negative 1. And then if n is equal to 2, we have cosine of 2 pi, which we know is equal to 1. So we get negative 1 raised to the 2, which is 1. So this formula checks out. So we have essentially a negative 2 over n times negative 1 raised to the n. And now this negative 1 out front, it's a negative sign, but we can represent as negative 1. So we have negative 1 times 2 over n times negative 1 to the n. Since these are the same bases, we can add the exponents. So we have 2 over n times negative 1 to the n plus 1. And that's going to be equal to our b sub n. So in total, f of x can be represented with this Fourier series n equals 1 to infinity of 2 over n times negative 1 to the n plus 1 sine of nx. Pretty cool.